Okay, so we're going to draw a few pictures here just to give you a little schematic breakdown, very simplified version. Okay. Alright, this is the side view of your brain. Okay, it's actually looking at us this way. Alright. Front of the brain, the back of the brain. Okay. In the central part of that brain is what I said is called the limbic system. That's where the hypothalamus resides. Now, information is constantly coming into the brain, specifically into the hypothalamus area. So we have all of this sensory input coming into the brain. The hypothalamus decides what it needs to do. And it's going to send a signal down to the pituitary gland. The pituitary gland sits down here. Now your thyroid, which we said at the base of the throat. So if the hypothalamus is recognizing that we need more thyroid hormones we need the demand for more metabolic activity, okay, the hypothalamus sends a signal to the pituitary with what is called thyroid releasing hormone. The pituitary gets that input. The pituitary then sends a signal down to the thyroid gland using what is called thyroid stimulating hormone. TSH, there's your measurement. Okay? The TSH stimulates the thyroid. The thyroid uptakes iodine to produce T4 and T3. Now remember, T4, 97%, T3, 3%. Inactive, active. The T4 and the T3 actually then need to move throughout the body. Remember, hormones in the endocrine system travel throughout the body to get to the targeted tissue. Okay, so if you're producing the thyroid hormone here in the manufacturing plant, and it needs to do some work in the digestive system, it's got to travel through to get to the digestive system. If it helps to need a broken bone mend, it needs to travel through to get to the broken bone. If your brain is requiring thyroid input, it needs to travel through and get to the brain. Okay? And so these hormones travel, and they travel via what are referred to as thyroid binding globulins. They're protein molecules that transports these hormones. It's almost like New York City cabs driving people around the cab to get from uptown to downtown. That's it. And once you get downtown, you get out of the cab. So the same thing happens. So you'll see a measurement which is called total T4 or total T3. Total T4 and total T3 means that it is bound to the protein molecules. Your body can't do anything with those. You've got to get out of the cab. So your body needs to detach itself, or it needs to detach the T4 from the protein molecule so that it becomes free T4 and free T3. That's very critical because total T4, total T3, body can't do anything with it. It's just a transport mechanism. So then it moves down and it's going to go to various tissues in your body where this activity takes place. Now the areas that it takes place, the largest area is going to be in your liver, and it's also going to be in your digestive system. And the third place will be at the target tissues themselves. But the majority of this conversion of the inactive T4 to T3 is going to take place at the liver, and some of it will move on into the digestive system. I won't get into the technicalities, what else goes on, but this is the basic mechanism. Now, once it is turned into the active form of T4 and T3, or I should say the free version, I shouldn't say, let me back up, free T4, T3, because T4, even in its free state, is still not, the body can't do much with it. So we need to get a conversion of the T4 into T3. And that conversion of T4 and T3 takes place in the liver, takes place in the gut, so that we have a ready supply of T3. Now let's say we have a target tissue. We'll call the target tissue, well, we can call it the heart. Right? The T3 needs to get to the cells of the heart. And so if there is a problem with the receptors for thyroid hormone, if those receptors aren't working properly, that even though all of these steps are working fine, the fact that it cannot bind to the receptors at the cell still makes the situation inactive. The point that I'm getting at is that just looking at this TSH is a very limited way of assessing the mechanisms that actually need to take place before the thyroid hormone is able to do its job, which is to produce metabolic function at the cellular level. So any one of these things can be broken down and not working properly. This TSH can be normal, but even though this is normal, the mechanisms down here are not working properly. If you cannot convert the T4 into T3 in the liver, it doesn't make a difference that that's okay. You're not getting conversion to active T3. This is one of the major reasons why your lab test can look normal for TSH, and there's no change in medication, but you still feel lousy because even though you have normal levels, your body is not utilizing the hormone effectively, and your system is still being deprived of the hormone, and you're not getting metabolic function. So your cells are not healthy. Their cells are tired or fatigued, and you get all these various symptoms. Now here's something that we really need to talk about. And this point is critical. I really want you to have ownership over this. There's two kinds of thyroid conditions, right? We have hypothyroid and hyperthyroid. Hypothyroid is when your body is slow. It's sluggish. It's a slow thyroid. Hyper means it's going too fast. Okay? There's a higher percentage in this country of hypothyroid than hyperthyroid. But here's what's most important to understand. Even though I'm showing all these various mechanisms that can be broken down, 90%, 9 out of 10 people in this country with a hypothyroid condition, it is caused by an autoimmune condition, an autoimmune response. Let me repeat that, 90%. 90%. 9 out of 10 people have an autoimmune response that is triggering their thyroid problem. What does that actually mean? This means that the immune system is attacking your thyroid. An autoimmune condition is where your immune system, which should be protecting us, has gone awry, it's gone skewed for various reasons. Okay, and that immune system is now attacking normal healthy tissue. And the number one or most common place is going to be thyroid. So when people have, and that is called Hashimoto's hypothyroid, named after a Japanese doctor who discovered this back in the 20s. What I really need you to understand with this is that if you have a Hashimoto's hypothyroid, what you really have is an immune problem, not a thyroid problem. The thyroid is like the innocent bystander that has a bullseye on it. Your thyroid isn't sick. Your thyroid doesn't need to be treated. It's your immune system that needs to be treated. You might ask, well then why is that not the case? Why are the medical doctors not doing this? Why is my endocrinologist not doing this? Because unfortunately they don't really have anything in their ammunition to do it, other than powerful drugs to suppress the immune system. So they don't run these tests because it's meaningless to them, because they're not going to treat it. That's why all they run is the TSH, because the TSH is the marker for Thyroid or some other hormone drug. And they'll monitor the blood to see if they need to increase the dosage or not. Now, if they know you have a autoimmune disease, a Hashimoto's hypothyroid, they basically just keep treating you with the Thyroid because they just know at some point that that immune system will eventually kill off the entire thyroid, and all they do is just keep upping your dosage along the way until the thyroid is completely shot, and then they just get you on a higher dosage of Thyroid. That's really what it comes down to. It's quite unfortunate.